Hello and welcome to today's class on organic chemistry. Now, why is it that we study organic chemistry, or what is organic chemistry? Basically, organic chemistry is the study of carbon and its derivatives, or the study of carbon and its compounds. So the question is, why is it that we study carbon? Why don't we study other elements like we study carbon? It is simply because of the following reasons. Number one is that most of the things we use, both in nature and artificial, are made up of large molecules of carbon. For example, human being is made up of large molecules of carbon. The food we eat are made up of large molecules of carbon, including the drugs and most other things we use in our everyday life. Secondly, is carbon has the ability to catenate. Catenation simply means that carbon can form long chain. Ability to form long chain. This is what we refer to as catenation. Okay, then the third one is that carbon has the ability to react with other elements like oxygen, hydrogen, nitrogen, sulfur. It has ease of reaction. And then the last but not the least is that carbon forms bond. It can easily form single bond, it can form double bond, and it can form triple bond. So this is the reasons behind the study of organic chemistry. Okay, having known this, we'll be looking at various concepts to organic chemistry. So the first concept we'll be looking at is the homologous series. Now, what is homologous series? Homologous series simply refers to the family of organic compounds where each member differ. It is a family of organic compound that has a regular structural pattern where each member differ by a CH2 group. They have a regular structural pattern and each member differs by a CH2 group. So that means to say alkane. In the family of alkane, their formula is CN2N2 plus 2. This is the family of alkane. Then in the family of alkene, their formula is CnH2n. This is the family of alkene. Then in the family of alkyne, it will be CN2N2 minus 2. So this is the family of alkyne. So let's look at the alkane family. Now, the first compound in alkane family is methane. That is C, carbon 1. So the first is 1. So carbon is 1. Then H is 2 times 1, 2 plus 1, 4. So this is called methane. Then the second one is second carbon atom. C is now 2. H will be 2 times 2, 4. 4 plus 1, 6. And the third carbon, where C is now 3, or where N is 3, it will be C3, H, 2 times 3, 6. 6 plus 2. 6 plus 2 will give us 8. So, if you look at this now, you will discover that they differ by a CH2. How? This is CH4. This is C2. So, the difference between this and this is that this has an extra carbon atom, so C. Then it has 2 extra hydrogen. This is 4, this is 6. So 6 minus 4, that will give us 2. The difference between this and this is the same thing. This has an extra 3 minus 2, that will give us 1. 8 minus 6, that will give us 2. So you can see that they differ by a CH2 group. Let's look at the alkene. For the alkene, the first compound is 18. The first compound is 2. So we have C2H 2 times 4. 2 times 2, that will give us 4. The third one is C3H 2 times 3, that will give us 6. Now, this minus this will give us 1. This minus this will give us 2. So, do you see the same CH2 group? For the alkyne, the family of alkyne, this is their formula, and this will be where N is now 2. 2 times 2, 4. 4 minus 2, 2. Where N is 3, 2 times 3, 6. 6 minus 2, that will give us 4. Okay, so this minus this is what? C. This minus this is 2. So this is how it happens down the group. So each family differs. Each of the family, there is a difference by CH2. This is for the homologous series. So let's look at the next one, the alkyl group. All right, so the alkyl group. The alkyl group is a family of organic compounds that are derived from alkane by a loss of 1 hydrogen atom. A family of organic compounds derived from alkane by a loss of 1 hydrogen atom. So what do we mean by that? Let's look at the alkane family again. The alkane family, remember their formula. So you have CN2N2 plus 2. We're looking at the first where N is 1. So this will be C 1. 2 times 1, 2 plus 2, 4. This is the alkane family. So let's look at the alkyl family. The alkyl family will be all the family of alkane that has a loss of hydrogen atom. So let there be a loss of hydrogen atom here. Remove 1 hydrogen atom, you will have CH3. This is an alkyl group. Okay, what about where N is 2? 2 times 2, 4 plus 2, that will give us 6. So a loss of an hydrogen atom, that will be what? C2H5. Then the next one is C3H. 2 times 3, 6. 6 plus 2, that will give us 8. So the alkyl group will be what? A loss of hydrogen atom, C3H7. So a loss of hydrogen atom from the family of alkane, we call them what? Alkyl. Down the group. This is only pertainable to the alkane family only. It is not pertainable to the alkene or alkyne, please. Alkyl groups are group derived from the alkane by a loss of hydrogen atom. Okay, so let's look at the next concept. So the third one is what we refer to as the functional group. So what are the functional group? The functional group simply refers to radical or bond that is common to a homologous series. Radical or bond common to a homologous series. Now, what is radical? Radical simply means group of atoms. Radical simply means group of atoms. Group of atoms. So the radical may be COOH. This is group of atom. The radical may be NH. This is group of atom. Or bond. Bond may be single bond, double bond, or triple bond. So radical or bond that is common to a homologous series, which determine the chemical property of the group, is what we refer to as functional group. Okay, so I'm going to be showing us the various functional groups that we have so that we can memorize them, and it's going to help us in identifying compounds. Okay, so let's look at the various functional groups we have. So you have alkane, and the functional group is a single bond. You have alkene, the functional group is a double bond. You have alkyne, the functional group is triple bond. You have alkanol, this is OH group. You have ethers, this is OR, O-alkyl. This is an alkyl group, O-alkyl. Then you have alkanals, this is the functional group. You have the alkanones, this is the functional group. You have the alkanoic acid, this is the functional group. You have the esters, this is the functional group, this is an alkyl. Then the primary amine, this is a functional group. The amides, this is the functional group. The nitrites, this is the functional group. So it is very important that we memorize the functional groups because it's going to help us in naming of our organic compounds. Okay, so the next concept we'll go into is what we call the saturated and unsaturated. The saturated and unsaturated. The saturated and unsaturated compounds. So what are saturated compounds? Basically, saturated compounds are those compounds that are single covalent bond. Those compounds that are single covalent bond, we call them saturated compounds. Example, this is a single covalent bond. So you say that this is saturated because they are single covalent. Whereas unsaturated are those that are double or triple covalent bond. For example, so as you can see, this is double covalently bonded, and this is triple covalently bonded. So this and this are unsaturated hydrocarbon, but this is what saturated. So when it has single covalent bond, it is saturated. When it has more than one, double or triple, it is unsaturated organic compound. Okay, so the last but not the least, we'll be looking at the hybridization. Hybridization. So what is hybridization? Hybridization. So what is hybridization? It is simply the mixing of two or more orbitals of the same principal quantum number in order to form a new orbital. The mixing of two or more orbitals of the same principal quantum number in order to form a new orbital. We refer to it as hybridization. Now, for alkane family, the hybridization of alkane family is sp3. The hybridization of alkene family is sp2. And that of alkyne is sp. So we'll be ending this class. So the last but not the least is how to find sigma and pi bond. So sigma and pi bond. Okay, so now for alkane family, the alkane family, they have one sigma. Then the alkene family, they have one sigma and one pi. So we can say single covalently bond, single bond have one sigma. Double bond, they have one sigma and one pi. Then triple bond, they have one sigma and two pi. So I come again, one sigma and one pi bond, one sigma and two pi bond. So let's look at this now and identify the number of sigma bond and the pi bond in them. So looking at the first one we have here, we can see that all of them are single covalent bond. They are single covalent bond. So that means the only type of bond you can find here is what? The sigma bond only. So sigma bond, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this organic compound has 13 sigma bond. 13 sigma bond. Okay, so let's look at the second one here. Now looking at this second one, you can see that it has a double bond. A double bond. That means the double bond here has 1 sigma bond and 1 pi bond. So let's count the number of sigma bond and pi bond here. So this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it has 13 sigma, but here there is a double bond here. And the double bond here includes 1 sigma, 1 pi. So 13 plus 1, that will give us what? 14. So it has 14 sigma bond and 1 pi bond. 14 sigma bond and 1 pi bond. So let's look at this third one here. How many sigma bond, how many pi bond? So this is 1, 2, 3, 4, 5, 6, 7, 8. 8 sigma. So here we have a triple bond. Triple bond has 1 pi. Triple bond has 1 sigma, 2 pi. So 8 plus 1 sigma here, that will give us 9 sigma. So we have 9 sigma and how many pi? 2 pi bond. 2 pi bond. Okay, so that is it. So in the next class, we'll be learning how to name organic compounds. Thank you very much for watching. Please do well to subscribe to our channel and also invite your friends to do the same. Thank you and bye.